Now let's identify some of the different parts of a polynomial. First of all polynomials have a degree. Degree is the highest exponent that appears with a non-zero coefficient. Just like that. Now remember, it's just the highest exponent that appears. We're not talking about the entire term. So for example, the degree of this polynomial would be 3, not x cubed. It would just be 3. So whatever your highest exponent of x is, you find it, and then that exponent is the degree. So for example, for this one, the highest exponent of x is a 9, so the degree of this polynomial would be 9. Keep in mind, we're not worried at all about our coefficients. We just want to know the highest power of x. And the reason why we want to know this is because the degree of a polynomial is one of the things that most influence its shape. The other thing that influences what a polynomial looks like on a graph is its lead term. And its lead term is coefficient that appears with the highest power of x. So for example, for the polynomial negative 3x to the fourth plus 2x minus 1, the highest power of x we have is 4, and the coefficient that appears with the highest power of x is negative 3. So this polynomial has a degree of 4 and has a leading term of negative 3. The constant term is whatever term that appears that doesn't have a variable attached to it. In our definition of polynomial, that term would be a0, but when you're looking at actual polynomials, it's just whatever number is there that doesn't have an x or an x squared or anything attached. Let's take a look at a couple examples and identify our lead term, constant term, and our degree. All right, let's begin with this polynomial. First, we want to identify the degree. And when we're identifying the degree, remember, the degree is not the power of x that appears first. It's the highest power of x that appears. Even though polynomials are traditionally written to have the highest power of x appearing first, sometimes they may mix that up, especially in homework problems asking you about the degree. So, the highest power of x that appears is right here. We have x to the 9th. So our degree would be 9, and our lead term would be the number associated with the highest power of x. So that would be negative 6. Now, as far as a constant term, every term here has a variable attached to it, and there is no number just by itself. So here our constant term would be 0. And there you have it. We've identified the degree as 9, the lead term as negative 6, and the constant term is 0. Let's do another one. All right, first, degree. The degree is the highest power of x that appears. In this case, that would be x to the 5th. So our degree is 5. Now, the lead term is the coefficient that appears with the highest power of x. In this case, it would be positive 4. Lastly, our constant term, just the number that appears in this, is 1. We've got a lone 1 over here. It doesn't have any variable attached to it. All right, not so bad. Let's try one more example. There we are. So let's start looking for our highest power of x. Got x to the 6th, bigger than x squared, but x to the 8th is going to be the highest power of x, which makes our degree 8. Lastly, our lead term is the coefficient attached to the highest power of x, which is negative 14 in this case. And lastly, our constant term, or the term without any variable attached to it, we've got this little 3/2 right here. So our constant term is 3/2. And there you go. Next, we'll learn how our degree and lead term can affect what's called the end behavior of a polynomial.